Hi, YouTubers. Dave out in Western Pennsylvania, USA. Just wanted to show you live capturing data on a step level, power output, and 10 measurements. You can see the start current, stop current, cutoff voltage 0.3 volts, steps 0.1 increments, and 10-second changes. I'm interested in gauging this setup, and that is a section of graphite felt, which also has a deposit of aerosol graphite on it, and a section, and I'm trying this for a reason, of course, of air filter. Now, I got this from Walmart, and I cut the accordion section. The top you're seeing is activated charcoal. We didn't do a scanning electron microscopic test on it yet, but we will. On the back is simply essentially paper. So I coated the graphite felt with a DES, zinc chloride, acetamide, 1:4 mole ratio, respectively. And I also coated the activated carbon, and I have it in a plastic sleeve, not totally closed. You can see the clips I use as current collectors. I use 18 gauge copper. The dimensions I will report. And I have it clamped down, but that accordion configuration flattens out with runs. But nonetheless, I clamped it down, and we can see the power output reaches a peak of 1.2 watts, and there's a series of 5 that are 1.0 watts or greater, and then it drops off, of course, with a current increase. But a 1.2 max, and that would be 500 to 600 milliamps, and the voltage there is about 2.47 for the number 5 and 2.07 for the 6th. So that's after a run of 50 cycles. And I will put that data up. I did 50 cycle run, and the columbic ratio as estimated by milliamp hours for the cycles is a pretty hefty 0.027 to 0.027, a 1-to-1 ratio, which is excellent. And I did write down some data for the cycles. And there was one, number 20, I looked at 5, 10, 20, 30, 40, and 50. And there was one that was, after 20 cycles, it was 0.027 versus 0.028 for discharge, but it's running smoothly 0.027, 0.027 for the 50 cycle run. And that was right before doing the step run, which you're seeing here. I'll upload some data, and I think this is a perfectly acceptable way to do first approximation of a graphite felt. If you modify it, of course, by nickel cobalt plating, oxidation, deposition of polypyrrole, which we're going to do. It's in series with 2 supercaps. I don't have resistors in parallel for each, but I stay well below the 2.28 or 5.6 volts. I usually am charging up to 4.6 volts. And that is a relatively safe way to avoid decomposing, destroying one of the supercaps. And I'm using alligator clips because I'm not moving this around. But make sure you have it in series, the 2 supercaps, and make sure you have the graphite felt in series with the circuit components. And I ensure then that the current going through must go through the graphite before reaching the supercaps. If you haphazardly put it in parallel, it may be bypassed. I'll also record the mass before and after these determinations, but this looks pretty promising. I really want to examine this graphite touching the graphite felt, because in a supercap prototype that I'll assemble, I'd like to have the strips of graphite with activated carbon touching each, and the paper touching paper of the other electrode when I sandwich them. Thanks for watching. We'll keep you posted on our work. Bye for now.